everyone, thanks for tuning in for our YouTube live session today. I'm Noelle, I'm on our recruiting team for our software engineering internship, and today I'm joined by two of our awesome engineers who are here to run through some interview tips and tricks and also run through a few mock interview questions with you guys during this session. So as a first step, as you can see on your screen now, if you're able to go to this link to mark your attendance, we'd love to know that you joined us here today. And throughout this session, myself and my teammate Andy will be answering your questions in the chat box. So feel free to use this to be as interactive as possible. We'll be answering as best as we can, and then any technical questions, we'll turn it over to the experts when we get a chance in the program. So that is all I have for us today. I'm excited to turn it over to our engineers for them to get started with you guys.
Thank you.
Hello, everybody. My name is Sion. I'm very excited to be here with you. So I am a software engineer here at Google. I've been here about a year. I work on the Android Partner Engineering team. I love it, and I hope I can be useful today.
And hi, everyone. My name is Edgar. I'm a software engineer here at Google. I'm from Mexico, and I went to the University of Tennessee for my graduate studies. Before joining Google, I was trying to be a scientist. And I currently work in search infrastructure in index selection for web and images.
So the technical interview, what can you expect? Most technical interviews consist of the first couple of minutes, which are a short introduction where the engineer will ask you a little bit about yourself, but a majority of the time is going to be spent doing a technical assessment in whatever language you prefer, that's C, Java, Python, after which there's hopefully a little bit of time at the end that they'll leave so that you can ask any other questions that you have.
Yeah, and what the engineer is going to be looking for when you are in your question is basically assessing your technical skills, figuring out how well you code, how well you know your data structures, your algorithms. And the most important thing that we're going to be looking for is for assessing your analytical skills and your problem-solving skills. Those are definitely the most important things. We try to hire generalists, and as such, we don't care so much into the solution itself. We care about good design principles. We care about how you are thinking through the problems. And Sion is going to go into a little bit more detail on that.
Yeah, so what is the actual interview like? Well, what we really want to know is how do you think? That's what the engineer is there to assess. Like, what problem do you have the right problem-solving skills? So that means we want you to think out loud. Just try to always be talking, expressing all the thoughts that are coming into your mind during the interview, and ask as many questions as you can to make sure you have a full understanding of the question before diving in. Sometimes the questions will be a little bit in-depth, but that's really just because we want to know how you handle complicated problems. So finding the right solution is nice, but it's really not the point of it. It's mostly just to make sure that we can evaluate how you think and how you solve problems.
Yeah, and so I'm going to be sort of walking you through the timeline of how you should be approaching roughly a coding question. So the first thing that an interviewer is going to do is going to propose a question for you to solve. And the question can be very ambiguous. And your first job is to clarify everything that question is. So you need to make sure that you understand what inputs you have, make sure that you have the right data structures, the right data types, that you understand what all of the requirements are. And if you have any assumptions, stating out loud. This sort of clarification part is definitely the most important. Make sure that you keep a good communication with your interviewer throughout, ask a lot of questions, and listen to the answers. Sometimes there's hints hidden in the answers that the interviewer is giving you. After that, basically you can start sort of defining what you're going to be doing, what kind of data structures you might be using, and what kind of approach. And from there, you kind of go into the actual proposing a solution. You start saying, okay, so the first thing that comes to mind is to solve it using this or another type of solution. And it's okay to start with the simplest solution and discuss it. But then again, it's important to state everything because your interviewer might change the requirements of the question as you are proposing solutions to make it more interesting or to explore a different area. And so this refinement process in which you're proposing alternatives leads ultimately to your interviewer and yourself sort of agreeing that you both know what you're going to be solving, and then it goes into the coding. And we're going to see this in the mock.
So what we're going to try to do next is demonstrate the technical assessment of the interview, where Edgar will be playing the role of my interviewer, and I will be the interviewee. And we'll try to break it up throughout the question to clarify like what an ideal candidate should be doing. Let me go to the question.
Right. So the question that I want you to solve is, given a collection of numbers, determine whether there are two distinct elements in that collection that have a sum equal to a target value.
Okay. So I just want to make sure I understand the question. So is it okay if I make some notes, write down inputs, outputs? All right. So from my understanding, I'm given some input. Can I make the assumption that it's going to be an integer array, or how am I being given these?
Sure. Yeah. For now, you can assume that it's an integer array. That's okay.
Okay. So I'm given some int array, and you say that it has the sum equal to a target value, so probably also some int n.
Sounds good.
And then you want me to return some true if in my array I find some two pair, if I find pair which sums to n. Is that what we're looking for?
Yeah, that sounds good for now. We can later figure out if we want to return the actual pair or something. But
okay.
Yeah.
All right. Let me see. Can I pass a couple of my assumptions by you? So will n always be positive, or?
Not necessarily. Yeah, it can be arbitrary.
Okay, so n can be any integer. N is any integer. Okay. And then, am I always guaranteed to have a fixed length of an array, or do I have to account for streaming?
I see. Yeah, that's an interesting question. Let's get it so that you have a fixed array.
Okay,
that's fine.
So it's a fixed array. Okay. All right. I think I have an idea of the question, but just to make sure, let me write a few examples. So I think the question already has some. So if I was given input equals, let's see, your example is 2, 4, 5, 9, and 1. I should be outputting true because n equals 7. I should output true because 2 and 5 sum to 7.
That's correct. Yes.
Okay. All right. I think I have a good idea. I'm ready to start discussing some approaches.
Okay, so let's break character here. So you can see that she did very well in stating her assumptions, in particular sort of asking whether the input was bounded completely or versus whether it was a streaming. It's kind of very important. At Google, obviously, we do things at scale, so very likely a follow-up question could always be what happens if the input is too big. Also, figuring out whether it was integers and what the return type was. I mean, the question was very purposefully underspecified. So whether we want the pair, whether we want a Boolean or not, those are important. And sort of the edge cases of what happens with negatives and all of that is very good. Yeah. Do you want to add anything to this?
No. I think this is the way that I normally go and try to break down a problem in a technical interview, even when I don't know how to solve it at that point in time. It really helps me to start by restating the question in a way that could be written into a method. So that means I'm given some input arguments and I have to output something. So at the very least, I know what should be given. And then stating some assumptions because there could always be some tricks given. So before assuming anything, I want to pass that by the interviewer, make sure they know how I'm thinking and what cases I'm considering before even writing out some approaches.
And then we have a question from the audience. Tebralicious asks, is better readable code more important than performance-oriented code?
Both are important.
Yeah.
Very readable code is definitely a big plus. In terms of optimality, we don't care about the absolute optimal question, but again, discuss it with your interviewer, right? If you are having a solution and the interviewer is asking you for a better solution, then it's probably going to be a hint that there's something that you could be doing better.
And if you do believe that you have one of your approaches that you're going to be implementing is suboptimal, you express that to your interviewer and let them know that, hey, I understand that the runtime on this might not be the best, but I can't really figure out how to improve it, so is it okay just to implement it so that we can assess my coding abilities? So by expressing that you've thought through that helps the interviewer know that these are things you're considering before implementing a solution.
Absolutely. So if we're ready, let's start discussing some of the solutions.
All right. I think I'm okay starting to discuss some approaches now. I'll just jot them down so we can talk over them. So I'm initially looking at this. I think I could solve it without really considering anything else. I could probably loop through this array, compare every single element to every subsequent element, and see if they sum up to 7. So that would be 2 to 4, 2 to 5, 2 to 9, 2 to 1, and then eventually go through it and output true whenever I run into something that equals n.
Sounds good. So what would be the complexity of that solution?
Well, since I'm doing every subsequent array for every single element in the array, it would probably be quadratic. So I'm thinking O of n squared. I think that there could be a better solution, but I'll write that down for now.
Yeah, sounds good.
So approach 1 is compare every elem to every subsequent elem. And before I start implementing that, I kind of want to see if there's something a little bit more optimal in terms of runtime. Let me see. What I really want to know is if I have a 2 in my array, I want to see if I'm going to run into a 5, n minus I. So how could I do that by 1 or 2 passes to improve this? Well, I guess what I could do is save each element into another data structure and check each one toward that data structure to see if that would improve the runtime. And it couldn't be an array list because then the runtime wouldn't improve.
Yeah, so what kind of data structure would you be using?
Either a hash map, hash set. Yeah, hash map would need key values, so a hash set is probably a better solution for this. So maybe I could save every element into the hash set and then compare it on the second pass. But then that would give me false positives because I could be comparing 4 and 4 when n equals 8, and that wouldn't work. So what I could do is save the elements as I'm going through it and see if it already has n minus my current element inside.
Mm-hmm. Sounds good.
Yeah?
What would be the complexity of that solution?
Well, I'm only passing through it once, so it would just be the size of the array. So O of n. Okay.
Mm-hmm.
Okay. So that would be, this is O of n squared in terms of time, and this is O of n. And my second approach would be save elem in hash set if n minus elem is not already in the set. So, and that has a better time complexity than this one. So I think I would probably go with this approach over that one.
Okay, but let's discuss. So in this one, you're right that the running time is O of n.
Yeah.
So this is time complexity.
Mm-hmm.
What about the space complexity, the memory?
Okay, so how much space is it taking up?
Yes.
Well, this one, I'm not really initializing any additional data structures.
Mm-hmm.
So that's just constant.
Okay, sure.
But I guess this one doesn't perform as well in terms of space complexity. It would be O of n because I have to, I have to save each element. It could be a maximum of the full length of the array.
That's right. The worst case is that every element needs to be added. That's good. So you can see that there's kind of a trade-off between running time and space, and I wonder if there's any other approach that could improve on any of these constraints.
Well, if I'm trying to improve time, I probably, that's quadratic and that's linear, something in the middle would probably be logarithmic.
Okay, sounds good.
So if I'm trying to, most logarithmic solutions are some sort of surge, binary surge.
Mm-hmm. Sounds good. Sounds good.
Okay.
Yeah. So we're just to clarify. So we're saying that hopefully there is an n log n solution that has some sort of space complexity.
Okay. So if I'm trying to get n log n, how do I turn this into like a binary search problem? Well, that would be if I would be assuming that they're sorted because I would either be searching a left or a right side. So maybe if I sort them and then I try to find n minus current element either on the left or the right,
Mm-hmm.
that could work.
Okay. Yeah. So if it's sorting, it's n log n, and then you can do it. Find it also in n log n at worst. Cool. So we have actually, what would be the memory requirement though of sorting? Which sorting algorithm would you be using?
Probably the most efficient. You could do quick sort, merge sort.
Mm-hmm.
So.
Do you know the memory requirement of quick sort or merge sort?
I believe it should be log n. So because we want to be, we'll be comparing either side of the array.
Right. So they're recursive algorithms, and the recursion itself is stack memory. So yeah, cool. So now we have three solutions that kind of have explored the trade-off between space and time.
Mm-hmm.
But for implementation, I think we should stick with this approach too that we have here. That's what I would like to see some code for.
Okay.
And again, we're going to break character here and sort of point out. So very good, very well organized, talking about the first approach, the second approach, making sure that everything is clearly spelled out. The interviewer has a perfectly clear idea of what would be the solution. If I were to ask her to code this or this, I have a pretty good idea of what would be. The discussion of space and time, obviously she knows her algorithms, obviously she knows her data structures, and you can see sort of the back and forth that the solution itself wasn't, I mean, the fact that she gave me a good solution didn't mean that the conversation ended, right? So we were actually now discussing the trade-off of one thing and another, and data structures and algorithms and all of that. Anything that you would like to add?
Yeah, so I started doing this in my technical interviews when I was interviewing for internship, and it just helped make sure that the interviewer or the engineer always knew what I was thinking. So even before I started coding, I wasn't going to be stuck halfway through the middle changing my mind because we'd kind of come to a consensus that this was the implementation that was the most optimal. It even in most scenarios, just kind of writing out one or two approaches, discussing a little bit of the runtime is just as important as actually coding it out.
Right, and another point that I want to make is that getting the perfect optimal solution isn't required. In fact, there is a sorting algorithm, heap sort, that actually has all of one space complexity. But the fact that the candidate didn't know that, it's not a big problem. We are still sort of exploring all of this. And that's kind of a trivia question in a sense, knowing the right kind of algorithm to do it. So what I did when I was preparing for my interviews was make myself a cheat sheet, right? When I was spelling out all of the sorting algorithms and all of the data structures that I could fit in one page and studying them before the interview. It's okay. You don't need to know everything perfectly. It's absolutely fine. And so I think now we're going to go into the coding. Oh, well, no, we have questions.
We have a few questions from the audience.
Awesome.
So when you're first asked the question, would you suggest that the candidate restates the question before solving it every time?
It's not necessarily restate, but probably for the purpose of clarification, you want to, it helps to kind of break it down into making sure you understand what exactly is expected, like what is the problem, rather, because sometimes it comes in a paragraph format similar to this one, and so by just clarifying, okay, well, the general idea of what I'm supposed to be doing is, given these things, I need to produce this result.
Great.
Yeah.
Okay, thank you, Erica, for asking that. Then we have one from Ense. How important is perfect syntax while coding the solution?
I would like to say absolutely not important at all. Just make sure that you don't have 10 mistakes, right? So missing a semicolon, not remembering exactly the name of a function, not closing a parentheses, these things don't really matter. It's the approach of problem solving that is most important.
Yeah. And I've run into situations where the engineer might not necessarily be the most fluent in that language. So I've primarily did most of mine in Java, but they might have done only C. So they're not themselves very picky about, oh, you have to make sure all your brackets are opened and closed. So it's more of a general idea of you kind of know how to implement it rather than making sure your semicolons and your I's are dotted and everything.
Great. And then we've got one from Kevin. So if you were working through your thoughts and you noticed that you actually made a mistake and went back and fixed it, would that count against you in the interview?
That would count for you. If you catch a mistake and you go back and fix it, that's fantastic. That's great, because that means that you will be doing those things when you are in the job. You're going to be looking at yourself, second guessing whether you're right or not. The worst thing that could happen is a person who believes they're right and they're not, right? So actually going back and checking your work and backtracking, it's very important. In fact, I did that in one of my interviews. I was halfway through it, and the interviewer was not telling me much. And I said, you know what, could I just restart this? I don't think I have the right solution. And the interviewer said, like, yeah, it's not very elegant, is it? It's like, yeah, and I mean, it worked, right? I was hired, I'm here, and so I think it actually counted for me.
And that's kind of one of the points of expressing your thought process is that they get to see you evaluating your own solution and catching your mistakes. And what we're going to demonstrate during the implementation stage is testing it out and talking it through before, I go and tell the engineer, I'm done, this is it, this is going to work great. It's more, I'm going to try to be critical of my own solution, make sure I catch as many edge cases as possible before turning it over for their eyes.
Great. And then just one more before we get back into the next section. From Annabella, do you suggest the candidate gives more than one approach if you only have one approach, or does that count against you in any way?
I don't think you need to. Sometimes there has been situations where I've only ever had one, and I will tell the interviewer, the engineer, okay, like this is kind of what I'm thinking right now, and I don't really see another more optimal way to do it, and discussing the trade-offs for this. And if they're like, okay, this kind of works fine for me, you can proceed. That's why communication is so key, because you want to make it clear to the engineer, I thought through everything, and this is the approach that I think that I want to continue implementing.
Great. Okay.
Okay.
Perfect.
All right, so I'm going to work on my implementation now. So I think what I'm going to do is write a method that does all of this. And we can just
name it. So let me start. So this question is really just a method that returns a Boolean, if I understand correctly. And it should, I'll just name it sum in pair. Or pair, yeah, sum in pair. Or pair with sum. And as we discussed, it takes in an int array. And it takes in another integer n. And I'll be returning a Boolean if I ever run into a pair inside of my array that sums to n. So, okay, and what approach I'm going to be going with is I'm going to save this each element as I'm looping through it into my hash set, and then return true if I do run into an element already in there that's n minus the current element. So to break that down, I guess I will just start off by initializing my hash set. So I'll just call it integers, elums. Just get the idea. And then I'm going to, I know I have to loop through every element in here, so I'll have some for loop that kind of gives me a reference to the current element. I'll just name that cur in array. And then what I want to do is if elums, my hash set, already contains n minus cur, that means I have in my, I've already run into this, a pair, I'm going to just return true. Else, I'm going to save my current element into my current element into my hash set. So let me kind of make sure I have this right. Oh, I guess after I finish, I'll have to return false. Okay. Because that means I've run through all my elements and I didn't run into any pairs. So let me walk through, let me make sure this is going to work for our example. So I think we had an input of 2, 4, 5, 9, 1. So if I go in here, I'm looping through my array here. I have nothing in my hash set yet. I check that my hash set contains 2. It contains n equals 7. I see if it contains 5. It does not. So I put 2 inside of here. And then I do this all the way until I get to 5. I see if my hash set contains 7 minus 5, which is 2. It does, so I return true, and then I'm done. Because can I assume that I can return at the first one, or do you want to? Do I just need to look for one pair?
Yeah, that's okay.
Okay. So I'll just, in that case, this works fine. And then this should also work for empty arrays because it will return false. Yeah, and it should work for all integers. So.
Sounds good. What other test cases would you use?
I definitely would test with empty array. I would test with 0, n equals 0, just to make sure it works there. And then I would, let's see where it could mess up. Duplicates, I would make sure if I have multiple of these numbers, so if I had 4 and 4 and n equals 8, that it works then. Yeah, I think those would be some of the test cases that come to mind initially.
Okay, and finally, we're breaking character again. So again, you can see she was explaining what she was coding. She was telling me every single thing that she was doing, and she didn't need to finish out every single thing, like saying integer again. I mean, we know the syntax; it can be verbose. It's okay to sort of say, okay, that's understood what's going to be there, right? The fact that she started with the if and then put, that it's one very important part, because if you flip this if, then you get a bug in which you can be putting something in and then checking if you have it. Like for instance, in the other case, the 8 would have caught that bug. With n equals 8, the 4, if you put it first and then you check, then that could give you a false positive. Very well structured, very tight code. Again, if usually the problems that we're going to be asking, if you need more than a few lines of code, more than like 20, maybe think about whether there's a better way of approaching the solution. We don't try to ask questions that require a huge amount of code, so that's very good. I think this is obviously very, very good quality code. So.
So I, at least for me, I do like to talk while I'm solving it out, because keeping that communication with your engineer is really key. And, when you do go off track, then they can catch it very early before you're, 15 lines deep into your solution. You can't turn back. And then at the end, it really helps. That's why initially you want to have a couple examples of making sure that I know how it should be behaving. I know that when I'm given this sort of integer, that it should return true or false. And so, after you're done, make sure to just go back and walk through it a couple times. Like, I know that at this point, this is what my hash set looks like. I know that halfway through, this is when it should return. Just walking through it, make sure you catch your edge cases before the engineer does. It's not the most crucial thing, but it really helps us know that you care about catching everything that could go wrong with your solution.
Okay.
Absolutely right. Yes.
So we're going to break for a few questions. So from Lynn, is it okay to use built-in library functions in the solution?
Absolutely.
Yeah.
Please.
Yeah, I think it's okay, but it's depending on the interviewer and the role you're interviewing for. Maybe if you're going to be for a much lower level role, they might ask you, okay, pretend you didn't have this library. How would you do it? Or can you describe a little bit of how it's actually implemented a little bit under the hood? But
yes.
That's more of if you're not doing for a general role. So for general roles, if you know your language and you know that there's a function that does this, you can say, hey, can I use this function? And they'll let you know if they're okay with it.
Yes, two comments on that part. If you use something, make sure that you understand how it works, or at least its complexity, or something in rough sense. And the reusing of other components is very important in software engineering, right? You're going to be part of a team. You're going to be working with other people. You can't reinvent the wheel every time. So it's very, very important to reuse pieces. Yes.
Great. Okay, and then from NSAE, should our solution always account for a null value?
I mean, you can go very wrong with a null. So it's good to just, in the very beginning, when you're doing those clarifying questions, probably a really good one to have asked was, can I assume that I'm always given an array and not a null value? So that's actually a really good clarifying question, or a test case to account for. Mm-hmm. And by just saying that, your interviewer will let you know, okay, don't worry about that, or yes, that's actually a really good point. Thanks for pointing that out.
Yeah, many times you asking the question prompts the interviewer to say, yeah, don't worry about it. Mm-hmm. But the fact that you asked, it only took you like 5 seconds, but it was good enough to give a signal to the interviewer. Mm-hmm. Yes.
Great. Okay, and then from Carlos and Annabella, would it be wise to propose a design of your code or flow your program before starting to write the actual code in front of the engineer?
I think that works. I've done that a few times when I haven't been completely set on an implementation, where I've just walked through, loop through all of this, and just in words, so that all they have left to evaluate you on is your coding abilities. So it might just depend on how much time you have or how unclear you still are with your implementation, but that works too.
Great. And then from Davina, if you do a phone and Google Docs interview, would you suggest emphasizing normal programming and not giving too much time to coding by hand?
Coding on a Google Doc is almost like coding by hand in a whiteboard. You don't get any of the nice auto completions or anything like that. And again, we're not asking to write very sophisticated code with special libraries or special things. So it's probably a good idea to still practice doing that. Again, we're going for the problem-solving skills rather than for the purity of the code.
Got it. And that being said, from Renee, is this on par with the difficulty of questions in these types of interviews, or does it just vary based on the interviewer?
That's a really good question. I have gotten this problem a few times, actually more than once, from different companies. And depending on how long your interview is, usually within a 1 hour time period, you can get something like this as like a warm-up question, followed by a subsequent question if there's time. So I would say that this is comparable to the level of difficulty that you can expect in about a warm-up question, or and if there's time, depending on how long it takes to solve, they might want to ask a follow-up question.
Yeah, and also you can make the discussion very open-ended, right? For instance, here we were discussing algorithms and trade-offs between memory and running time, and we didn't even touch the possibility of having a stream instead of an array. What happens if you have 1 trillion elements that you need to be checking for? What happens if they don't fit in a hash set? Things like, a question that is deceptively simple can still be extended with follow-up questions into something that there's basically no right answer, right? So you could definitely do that. So I personally like starting with very simple questions that build up into a research problem. But some people do this other part of having a simple warm-up and then a more meatier second part question. It varies by interviewer.
Great. And then one more before we move on. This one's from Chinadum. How do you approach getting stuck on a question and not having a breakthrough moment or alternative solutions?
So getting stumped, that does happen. So I think this is why communicating with the engineer or the interviewer really helps, because it's supposed to flow like a conversation. So if you're stuck, you want to be expressing exactly what's going through your mind. Like, why are you stuck? You can't figure out how to make it more efficient. You can't really understand what it's supposed to output. So there's a reason that you're not able to move on. And when the engineer knows exactly at what point you're kind of hitting a wall, they're there to also give you a little bit of hint to move you along, so that they can much better evaluate you.
What she said.
Great. Okay, so we'll pause there and we'll ask a few more at the end.
Okay.
Sounds good. So we're going to show you a second practice problem, and we're going to discuss it. We're not going to go through the whole interview, but we'll show you this. And so basically the idea is that you could be asked this one, right? So implement a set-like data structure with 3 methods. Insert an element, remove an element by value, and return an element chosen uniformly at random. Right, and again, this question has multiple solutions, some of which are simple and some of which are more complicated, right? So if you want to sort of start.
Yeah, so similarly to how we approached the first question in the mock interview, I would probably start off by doing a couple of clarifying questions, like, all right, so you just want me to create a data structure, and I need to support, probably insert, remove, and return, or maybe that's probably kind of like a get, and then it seems like the trick is that it's at random. So maybe if I was like dropping things into a bag, it has to perform some sort of way like that.
Right. So this data structure basically behaves like a bag in which you drop marbles and you can sort of pull them out.
Okay.
So that kind of insight is important, right? And so the underlying data structure let's discuss a couple of alternatives of which underlying data structure we could use.
Okay, so it seems like instead of these marbles, what we're actually inserting is integers. So in the example, it looks like 1, 3, 7, 2, and 9. And we just want to have our get function of this structure kind of just pick one at random. So I probably have to store these things somewhere. So I'm thinking my data structure, along with having the 3 methods, would probably need to store these values somewhere. So I mean, I could do a list. I could do a set.
And both of those solutions have some, like a hash set versus an array list, have like a constant complexity for 2 of the methods and linear time for the third one. Okay. So if you have remove with an array list implemented in a trivial way, then it's a linear solution. If you have a get random from a hash set, then it's also, again, linear because you need to iterate. Mm-hmm. But there's better solutions, perhaps?
Well, so the trick seems to be that my get, which needs to return something at random, the way I have to do that is I probably just want to choose a random index. So a list might be better than a set because then I can kind of choose a random index in my data structure. So I think what I would probably do is inside of my data structure, I would initialize some array list. My insert would be adding to the end of the array list. My remove would be removing an element in the array list. And then my get would be getting a random integer from the length of the array and then removing that.
That's right, yeah. So the optimal solution in terms of running time for the 3 is a combination of the hash set with the array list. And you don't actually have to do that in an interview again. Discussing the trade-offs and everything is part of the solution. Basically, the idea is having a hash map of the values where their index is within an array list, so that the remove can be by index very easily, and you still have all of the benefits of having the array list for the get random and for the insertion in very fast time. But anyway, again, it can be extended. There's also a logarithmic solution for the three operations that can actually support even a 4th operation for a follow-up. But again, so this discussion, this kind of approach of going through things is the right way. So, yeah. Let's see, how are we doing for time?
We have another question.
We have questions, perfect.
So how many questions would typically be asked in a single phone screen? And would an interviewer ever be concerned that the candidate is not coding quickly enough?
So I think it varies because it's definitely candidate to candidate, and however the engineer likes to prep for it. So we do like to prepare, like most engineers like to prepare quite a few questions just in case we have a candidate that goes through all of them very fast. But sometimes one question can take up the whole interview just from, discussing a lot of trade-offs or if, the candidate took a little bit more time writing their implementation out. But it's definitely not the deciding factor on whether or not you'll move forward. It's just going to be like it just took more time. So you can expect that the engineer will have questions prepped for you all the way till the end of time. But it's okay to just take a little bit longer and not go through all of them.
Yeah, 1 and 2 interview questions is typical, I would say, especially for a phone screen or an on-site. That's kind of what we were discussing, a warm-up and a more sophisticated question later, or just one that keeps getting extended. Mm-hmm. That's typical. In terms of the speed, I would say don't worry too much about it if you are expressing yourself very clearly and you're expressing what your thought process is. Of course, there is a limited amount of time. The only problem with having a slow coding candidate is that we get less time to evaluate what the skills are, and I would say that's the...
Our goal is to figure out how you're thinking, how you're approaching, and so there's not really like a time limit on that. It's more of if we can't really get that much out of a candidate, then we don't know how well they'll perform in various settings.
Yes.
Great. Okay, we have a few more. So from Rachel, would most interviewers hint at the optimal solution or data structure, or just want the candidate to run with their instinct?
I don't think they would sabotage you.
No, I would say that it varies from interviewer to interviewer, definitely. But most interviewers want to give you hints because they're very excited about the question. They ask the question because they like it, right? So, and if you're almost there, they would give you like a hint of saying, "Oh, but what if things were sorted or something?" I mean, just sort of to get the ball rolling. Again, that doesn't mean that you need to have the best solution, but be very, very careful. Listen very carefully to what the interviewer is saying, because sometimes there's hints where you don't expect them. I remember one person was asking me, "So how do you feel about the structures?" And I'm like, "Well, they're nice." And then like after the interview, it's like, "Oh, of course, that's what they meant." Arg. It's okay.
Yeah.
Great. And then from Raghavan, what do you expect in a dynamic programming question? For the candidate to solve it or go through it?
Goodness. I would say dynamic programming is not a solution that you're expected to come up with on the spot. If you can, well, all the better for you. That's great. But I don't think we ask questions with a specific solution in mind.
Because it's an ideal question that an engineer gives is multiple ways of solving it, and it shouldn't have a gotcha factor where you've run into it at one like point in your life and you know that there's a really trick solution to it. That's not a very good question. And so if that is a question you've gotten, it's not a very well thought through one. A question should be able to you should be able to talk through it and come up with like some way of solving it. So a lot of engineers prefer not to give those if they do seem like, oh, it's gotcha. Like I know the exact algorithm that you have to do to solve this.
Okay. Then we have a last question from Truth before we move on. Anything you recommend the candidates do not do? So common mistakes, things to avoid, etc.
Don't be absolutely silent. That's a definite no-no. We cannot evaluate if you're completely stuck or if you're thinking about the absolute best solution. There's just nothing we can assess in that case. Don't be rude to your interviewer. Definitely don't do that.
Yeah. I think for me, I've run into a lot of candidates just starting a solution. Don't preemptively just start coding because you'll catch a lot of these things that could go wrong if you had just asked a few more questions in the beginning. And really stressed, I could tell that sometimes they might have not really fully understood the question, or if they just asked one or two more questions to make sure that they knew what they were doing, maybe discuss their approach in a little bit more detail before coding, that they could have avoided, starting a solution and going to the end and using up a lot of time.
Don't assume a magical function that solves the problem automatically, right? So if you're gonna say, oh, there is a library that does this, make sure that you understand what's going on there. Usually assuming that something magically will just solve the things for you will not help you much.
Any more questions?
Yeah, well, we can go for resume tips. Yay.
So Meliku asks...
More questions.
No, more questions.
More questions.
That's good.
That's a lot. How much expertise do I need on algorithms?
I would say I don't know how to quantify it other than about same as a data structures algorithms course. So you'd want to know your search algorithms, tree traversals, things like that. But about if you do enough of these practice problems, I think you'll get an idea of the areas that maybe you need a little bit more practice in. But yeah, I think if I had to quantify it, it would be about the same as a data structures algorithms course.
Yeah, I mean, it depends on obviously your seniority, right? If you're going for an internship, we're not going to expect you to be like a algorithms and data structures expert. That's okay. And even if you are like a seasoned coder, maybe data structures is not your thing. So as long as you know sort of array lists, vectors, hash maps, and sorting algorithms, something like divide and conquer, and a little bit like binary search, tree traversal, basic trees. Beyond that, not very.
About
very
the
much.
Fundamentals, because most of that, the more complex things can be derived from the fundamentals.
Mm-hmm. Yeah, definitely hash maps is something that you should know. But if you start getting into more sophisticated data structures, that's probably not needed. Perfect.
All right, so we're going to be talking a little bit about resume tips. So before you get the technical interview, you have to, get the actual interview. So what should you have on your resume? So this is a pretty good guide for what probably should stand out the most on your resume. And I like to think of your resume as sort of conveying these four kind of information very clearly. So it can be as fancy as you want, but just make sure that at the end of the day, it's conveying the fundamental information that they need. So that could be like your school, major, GPA, expected graduation date. If you've had internships before or you've worked on research projects, that's also really good.
Right. If you have also technical projects on your hobbies, like you have open source contributions, you have been in hackathons or things like that, that's also very important. It shows initiative. It gives us some flavor of what kind of code you write as well in a more sort of realistic environment than in an online coding session with an interviewer. Definitely, if you have activities that you want to highlight, involvement in clubs, groups, or associations, if they're technical, if they're relevant, that's great. Try not to pad too much the resume. Less is more. Definitely try to keep it very clean with a lot of white space, bullet points with phrase fragments rather than actual walls of text. We receive like literally millions of resumes per year, and we have people looking at all of them, and so they don't have a lot of time to do it. So a good practice way of doing this is if you give it to a friend and take it away 1 minute after, ask them what they got out of it, right? So real estate in the page, keep it to one page, right? It needs to be very clean, and if you are going to be putting something important, put it on the left of the page, dates and things like that. You can just leave on the right where they're not obstructing anything else. So name of the university, degree that you're pursuing, important projects with 2 bullet points. That's kind of the thing that we're talking about. Yeah.
Okay. And just last thing about the resume. If you don't have the work experience, and maybe this is the first internship you have, open source and personal projects, maybe if you were setting up your own small website, portfolio site, and hackathon projects, that also works comparably well.
Yeah, and one thing that I forgot to mention is that it's okay to say which skills you have, right? So like C++ and Java and sort of some sort of other part like development of drivers or something. Anything that can be sort of bullet pointed like that is good. Don't put 10,000 languages. If you say, oh, well, I know Java, C++, CSS, HTML, SQL.
Can you defend all of them?
Yeah, that's the thing. Everything that you put in your resume, it's fair game for someone to be asking you in an interview, right?
Yeah.
So don't say that you're an expert in C++, because then you can get an expert in C++ asking you questions. So yeah, that's I think basically the most important part. Just be factual, don't boast, just state the things that are.
Yeah.
Questions.
Yeah.
We just have one question. For someone who's a junior in college, is it okay for them to have a resume that's longer than 1 page, or would you suggest to keep it at that length?
That was me. I was a junior in college, and I had a resume that was 1.5 pages. And the feedback I got from every single recruiter at career fairs was, I really like your resume, but you have to cut it down to 1 page. And so I think a really good way to get feedback on that is when you do go to career fairs, ask the recruiters. If you'll get a general consensus of what they like by just asking them, do you have any, at the end of speaking to them, do you have any more feedback for me? Like, how could I improve this? And they'll more than likely, like, you don't usually have enough experience by your third year in college that can't be cut out and fit into a page.
Yeah, I feel you. It's very, very difficult to cut those things that you're so attached to out of your resume. But think about it this way. You don't want to dilute your skills. You don't want to dilute your achievements. If you put everything that you have done, then it's very difficult for a person casually looking at the resume to know which ones are the most important and which ones aren't, right? So if you have a PhD or 3 or 4 years experience in industry, 2 pages might be okay. If you don't, then stick to 1 page at all costs. Yeah. And even if you have 2 pages, make sure that whatever you put in the second page could be skipped.
Yeah.
So the first page should be standing on its own, basically.
Okay, great. And then from Critical asks, I used a language in one school project. Should I list that on my resume? I know the basics, but not anything advanced.
So the question is, should they include a language that they've only mildly had experience with? One way that I've seen students kind of present that on their resume is by saying, I'm fluent, I'm proficient, or I kind of have a little bit of experience. And so that they know that if they're getting an interviewer, that they wouldn't know all the nuances of that language.
Yeah, my suggestion would be don't put it in the skills, but put it in a bullet point of the projects that you worked on, right?
Yeah.
I think we're good for now.
Mm-hmm. Very good.
Okay. All right, make sure to mark your attendance. Thank you so much for, making it through with us. We had a really great time and hope we helped.
Yeah, thank you very much. And join us tomorrow at 5 for another session.
Yeah, thank you.
Goodbye, everyone.
Bye.
Hope you found this useful.